So in this video we're going to look at questions 16 to 20 in exercise 3b, projectiles on a horizontal plane. So in part 1 we're told if sine A is equal to a half, find two values of A where A is between 0 and 360. And you all know this is your unit circle. Question, sine A is equal to a half, so the inverse sine of 1 over 2 or 0.5 is going to give us 30 degrees. So there's one solution, 30. So based on your knowledge of cosine, all sine and tan being positive and negative in certain sectors, we draw our 30-degree angle here, and my angle that's actually there is from start to the line, so this angle is 150. So 30 or 150 are my two answers for part A. In part B, we're told a particle is fired from a point on a horizontal plane with initial speed 28 at an angle A to the plane. If its range is 40, find two possible angles of projection, similar to what we had in part 1. There's two possible angles. So my vector of u cos of the angle of projection times I plus u by the sine of the angle times j is equal to 28 cos A in the I direction plus 28 sine A in the j direction. And we're told the range here, so we're told s of x, and we know from previous that the range is going to be, well, there's two versions of the range. What we used in the last couple of questions, 2u squared sine alpha cos alpha over g, and 2 sine alpha cos alpha is equal to the sine of 2 alpha. So because we were dealing with sine alpha, I'd imagine that's what they're looking for here. So let's change this to sine 2 alpha by u squared over g is equal to my range, which is 40. So simplifying this out, we're going to get, let's come under the circle here, we're going to get the sine of 2 alpha by u squared, which is my 28 to be squared, is equal to 40 times g, or 40 times 9.8. So sine of 2 alpha is equal to 40 and 9.8 divided by 28 squared. And that actually works out even here. That's sine 2 alpha is equal to half, which brings me back to the first part of the question. So therefore 2 alpha is equal to those angles 30 and 150 is 2 alpha. So alpha, like these trig questions from leaving cert maths, we divide by 2 to get 15 degrees and 75 degrees. Question 17, a particle is fired from a point on a horizontal plane with initial speed 10. Greatest height this time reached is 2.5. Find the sine of the angle of projection. So we know that greatest height, I'll call it h in this case, we use s for displacement if you're using the formula. It's going to be u squared sine squared alpha. Obviously the more you practice with these, it just becomes second nature to write down u squared sine squared alpha over 2g, and in this case my greatest height is 2.5. So u is 10, so 10 squared sine squared alpha is equal to 2.5 by 19.6, which is my 2g. So sine squared alpha is equal to 2.5 by 19.6 divided by 100. On a calculator, or 2.5, 19.6 is 49, so this is going to give me 0.49. So the square root of 0.49, sine alpha is 0.7. We could get the inverse if we were asked for it, but we're actually just asked for the sine of the angle, so 0.7 is the answer to this one. In question 18, a particle is fired so as to have maximum possible range. Show that the angle of projection should be 45, and the ratio of greatest height to range is 1 to 4. Okay, so we write down a formula from range and just have a look at a few options here. Range 2u squared sine alpha cos alpha over g So I think we looked at the previous question saying the max range was u squared over g. And let's have a look at y. If I take my really common 3, 4, 5 triangle, doesn't matter where the 3 and the 4 are. So cos A is equal to 4 over 5, and sin A is equal to 3 over 5. Now if we say 2 cos A sin A be equal to twice 4 over 5 times 3 over 5, which is equal to 24 over 25, which is slightly less than 1. So what gives a max value for this sin A cos A? Now it's in my 45-degree triangle. If this is a 1 and a 1 in ratio sense, this is root 2, so sin A is equal to 1 over root 2, and cos A is also equal to 1 over root 2. So cos A sin A is equal to 1 over root 2 by 1 over root 2, which is equal to 1 over 2. And if I multiply that by 2, I'm going to get an answer of 1, which gives me this max value for u squared over g. Because if it's less than 1, it will be going down, and if it's greater than 1, it'll be going up, but it can't be greater than 1, this sin A cos A. So that's why this max range is u squared over g. So let's look at the ratio of the greatest height to the range and see is it 1 to 4. So I have my range. So let's look at the max height. Max height, again, write the formula out every time. U squared sine squared A over 2g is the max height, which is equal to u squared by sine squared A is 1 over root 2 by 1 over root 2 divided by 2g, which is 1 over 2 times u squared divided by 2g. And to simplify it, if I multiply top and bottom by 2 over 2, which is just multiplying it by 1, it won't change its value. That will be equal to u squared over 4g. So my ratio, u squared over g to u squared over 4g is equal to 1 to 4. The opposite way around to what I've written it here. The 1 is obviously, that's a quarter of that one. So the height gives me my 1, and the range is my 4. Question 19. A ball is kicked from a point O on a horizontal with initial velocity pi plus qj meters per second. It lands at a point R 60 meters away. The greatest height above the ground is 5.625 meters. Okay, so we have 60. We have my greatest height, 5.625. We're asked to find P and Q. Okay, well, let's look at our 60 first. The displacement in x is equal to my initial velocity times t, ut. So in this case, pt is equal to 60. So that gives me one equation. I could also find this value in the displacement in y is equal to 0 at this point. So that's going to be ut plus a half at squared. And the time has to be the same in these. So my initial velocity in y was q. So qt minus 4.9 t squared is equal to pt. Is equal to 0. Obviously, not pt is equal to 0. So if I can get t, I'll be able to find out what p is. If I can get q, I should be able to get q at the greatest height. So my greatest height, I'll just call it gh. V squared is equal to u squared plus 2as. My velocity is 0 at this point. My u is q squared. And I have my greatest height, so I have plus twice minus 9.8 by my displacement, which is 5.625. So this works out to be q squared is equal to 2 by 9.8 by 5.625, which is 110.25 So the square root of that is 10.5. So Q is 10.5. That will enable me to get T, which will enable me to get P. So up here, I've got 10.5T minus 4.9T squared is equal to 0. If I take my T outside and multiply by 10.5 minus 4.9T, I get my initial T is equal to 0, and I get 4.9T is equal to 10.5. So T is equal to 10.5 over 49. 4.9, I'm jumping ahead of myself now. If I multiply both of them by 10, I get 105 over 49, and 7 divides into both of them. 7 into 105 is 15, and 7 into 49 is 7. So that's my T. So if I go back up here, I'm going to get P times 15 over 7 is equal to 60. So P is equal to 60 times 7, 420 divided by 15. So P is equal to, is that going to give me 4 sevens? 28. 28. So now we're asked here, find the greatest distance. Actually, a player runs, sorry, part 2 is longer one. A player runs at 7 meters per second from the moment the ball is kicked and arrives to catch the ball as it lands. Find the greatest distance that this player could have covered. Well, he's going 7 meters a second, and the ball took 15 over 7 seconds. So his speed by the time is going to give me, he could have covered 15 meters maximum in 7 seconds. In question 20, a particle is fired from a point on a horizontal plane with initial speed u. So it's another ratio question. The ratio of greatest height to range is 2 to 7. Okay, let's look at greatest height to range, 2 to 7. So just write down your formula again. Greatest height is going to be equal to u squared sine squared alpha. U squared sine squared alpha over 2g. And my range, 2u squared sine a cos a over g. So the ratio, the range is greater than the height. So I multiply the range by 2, twice the range is going to be equal to 7 times the greatest height. And we're asked to find the angle, so we need to solve down here. We'll probably end up getting a tan in this question. So twice the range is twice 2u squared, I'll give it a bracket actually, twice 2u squared sine a cos a over g is equal to 7 times u squared sine squared a over 2g. So I can divide by, or multiply by g. I can divide by u squared. Don't cancel off too many. So what have we got left? We've got 4 sine a cos a. And actually, I'm going to multiply that 4 by that 2 as well. So I'm going to change that to 8. Sine a cos a is equal to 7 sine squared a. You can see the same thing happens in a lot of these questions when they're ratio. So if I divide by sine, I'll do it a long way. Divide by sine. I'm going to get 8 cos a is equal to 7 sine a. So sine over cos, so I need to divide both sides by cos. To get, now you could skip all the, you can obviously do this a little bit quicker if you wanted. 8 is equal to 7 tan a. So 8 over 7 is equal to tan a. And the inverse tan of 8 over 7 on a calculator is going to give me 49 degrees. So that's the end of exercise 3b. Make sure you've practiced all these 20 questions. Repetition is the key, and then we'll move on to target practice in exercise 3c.